Hello and welcome to this session. In this session, we are going to learn about the fifth and final design principle. This is the D in solid. It stands for Dependency Inversion Principle, often abbreviated as DIP. Let's look at what this principle says. It goes like this: high-level modules should not depend on low-level modules. Both should depend on abstractions. Hang on, there is another part to it. Abstractions should not depend on details. Details should depend on abstractions. So there are two parts to this principle, but the fundamental concept behind both parts is the same. One follows from the other, as you will see shortly. Before we understand the principle, it's important that we understand the terms used in the definition. Let's take the terms high-level modules and low-level modules first. Say you are running an e-commerce website. The software for the e-commerce web application is sophisticated and contains tens of thousands of lines of code. But if we were to come up with a very high-level design model, this is what it would look like. There are three major business functions: product catalog, payment processor, and customer profile. These in turn depend on a number of other modules shown below for the implementation. So the modules on top are closer to the business functions and are called high-level modules. The modules towards the bottom deal with the implementation details and are called low-level modules. So the bottom modules are SQL Product Repository, Google Pay Gateway, Wire Transfer, Email Sender, and Voice Dialer. These deal with the low-level implementation. How about the communication module? Is it a high-level module or a low-level module? Trick question, huh? Well, the answer is it's both. If you consider the customer profile and the communication module alone, customer profile is the high-level module and communication is the low-level module. But if you consider the communication and the email sender module alone, communication is the high-level module here and email sender is the low-level module. The point here is that whether a module is a high-level or low-level module is relative and not absolute. Let's see our definition again. The first part alone for now. So we have covered the terms high-level module and low-level module. Back to the diagram. Note the arrow from product catalog to SQL product repository. This arrow should be read as depends on. So product catalog depends on SQL product repository. Product catalog, a high-level module, depends on SQL product repository, a low-level module. So this directly conflicts the definition. The definition says high-level modules should not depend on low-level modules. Both of them should depend on abstractions instead. Let's take this particular relationship alone and analyze it further. Let's try to come up with some code snippets for this relation. So we have a SQL product repository class which contains a method called getAllProductNames. Assume this method contains the code to run a select statement from a product database table in the backend. This method returns a list of product name strings. Next, we have the product catalog class. Here we first instantiate a new SQL product repository object, and then we call the getAllProductNames function on the instantiated object. So product catalog directly depends on SQL product repository. So this is the violation of the principle as seen in code. Now let's see if we can fix this violation. Let's go back to our definition for guidance. Both should depend on abstractions. So the definition gives us some guidance on how to fix this violation as well. So let's try it out. We will create an interface. An interface is an abstraction, and we'll call it product repository. We will make the SQL product repository implement this interface. Okay, so now we will need to get the SQL product repository object to the product catalog somehow. How can we do that? We should not directly instantiate the SQL product repository object, so we will use a factory class for the same. This is what the factory class looks like. It has a single method called create, which instantiates and returns a new SQL product repository object. Pretty simple and straightforward. Now, from the product catalog class, we will invoke this factory method, which will instantiate and return a SQL product repository object. But note that our reference object is product repository, so we don't have any tight coupling with SQL product repository anywhere in the product catalog class. Let's go back to our definition now. Both should depend on abstractions. Let's see how the dependency looks like now in the code after our restructuring. So product catalog, which is our high-level module, depends on product repository, which is an abstraction. So let's draw an arrow here. Next, SQL product repository, which is our low-level module, depends on product repository again because it implements it. So let's draw another arrow here. Now let's modify the figure on the left accordingly. We have the product repository which sits in between. This is what we call the abstraction. As you can see now, we are no longer violating the principle. The high-level module does not depend on the low-level module anymore. We went as per the definition, so both our high-level and low-level modules depend on the abstraction now. Let's bring up the second part of the definition now. Abstractions should not depend on details. Details should depend on abstractions. Look at the diagram on the left again. The dependency arrow, which was earlier pointing towards the SQL product repository, is now pointing in the opposite direction. That is, it is pointing away from SQL product repository. So now the detail, which is the SQL product repository class, is dependent on the abstraction, which is the product repository class. This is strictly as per the definition. The arrow changing direction is at the core of this principle. This is called the inversion of dependency, and this is the reason why this principle is called dependency inversion principle. So to sum up, we started with showing a violation of the dependency inversion principle. We understood what the violation is, then we took steps to restructure the code so as to strictly follow this principle. That's it for this session. I'll see you in the next one.